Video, I want to talk a little bit more about the properties of inverse functions. So once again, we have here, this is the definition of the inverse function f inverse, assuming that we are working with a one-to-one function f. So first thing is on this slide right here, we have these two properties that basically if you compose f inverse with f, or you compose f with f inverse, so composing the functions in either order, you always get back the original value. F inverse composed with f of x is equal to x. F composed with f inverse of y is equal to y. Of course, we need to be particular about what the allowable values here are x of y. So all x in the domain of f, all y in the range of f. That is what these formulas are good for. Furthermore, we can draw pictures here geometrically. So suppose that this is my function here, that this is f of x. So y is equal to f of x here. Let's draw a picture over here of what y is equal to f inverse of x looks like. So remember, domain becomes range, and range becomes domain. The range of our original function is the domain of the inverse, and vice versa. So here is our domain, and so that should mean the range is roughly from here to here on this new set of axes. And what is the range? This is the range, so the range should be over, sorry, the domain of the inverse function should be over here. And so if we just think a little bit about what's going on at, so like this point right here is corresponding to, the smallest possible value of our range over here. And so it should be corresponding to the smallest possible value of the, that should be the smallest down here, the smallest possible value of the range over here. And then it's going to be increasing like this. And so a little second thought, so we can take this picture and draw a corresponding new picture here. And you think about it, the connection between these two pictures is that you can get one from the other merely by reflecting it over the line y is equal to x. So just from one picture, we are able, if I give you a picture of a one-to-one function, you should be able to draw me a picture of the inverse of the function. Okay, one more little note in this section of in this video for this section. Logarithmic functions are just the inverse of exponential functions. So if we have y is equal to let's say e to the x, our favorite exponential function, the one we'll be using most frequently, and draw a picture of it, we can see that yes, it is a one-to-one function. It is passing the horizontal line test. That's going to go up very steeply, and this is always decreasing, so it will always be, it's never levels out completely, so it will pass the horizontal line test. And so then, the inverse, so if this is f of x, f inverse of x is the natural logarithm of x. So exponentials and logarithms are inverse functions of each other. And in fact, once again, I can draw a picture of what the log of x looks like. So this is e to the x and this is log of x, and once again we see that you just reflect things over the line y is equal to x.